طيب بسم الله الرحمن الرحيم. So we started to talk about the second generation wireless GSM. We talked about the architecture. We talked about the basic subsystems, the base station subsystem, the network and switching subsystem, and the operational subsystem, and the function, the main function of each of the components. And we started to talk about handover. We said that one of the fundamental changes that GSM came with was the concept of handover. And this handover really led to a revolution in terms of wireless services. And we talked about the concept behind handover, the fact that we take the measurements from the mobile stations in each cell. We have some measurement reports from all the mobile stations connected to any base station. And these instantaneous measurements gets averaged out using like some filtering or moving average filter. And then based on these average measurements, we have like some handover margin based on which the BSC or the MSC, depending on what type of handover we're talking about. We said that there are 4 types of handover. There is intra-BTS and enter-BTS and enter-BSC and enter-MSC handover. There are 4 types. So the BSC or the mobile switching center, depending on this handover margin, it might decide to trigger the handover process. So the mobile station will be deassociated from one base station and moved to another base station where the signal is actually better, in which case the channel of this mobile station to the new BTS is supposed to be significantly better, and this will lead to better service, hopefully. So we said that this handover margin is used to avoid ايه بقى اللي هو الايه البينج بونج effect, right? Because based on these instantaneous measurements, we might have to switch back and forth between the base stations, the new one and the old one, and so on. So to avoid this, we have to make sure that there is like some margin. We have to pass certain margin before we perform this handover. So assuming that we have reached to that state, and now we need to trigger the handover. So what is the sequence and what is the chronological events that happen to perform the process of handover? That's what we need to start talking about today. So this is the procedure for handover. Here we are trying to hand over not only from one base station to another, but from a base station that belongs to a base station controller to another base station that belongs to another BSC. So this is what we call a enter BSC handover. Of course, as we can see, the procedure is lengthy a little bit. It starts with some measurement report. These are instantaneous channel measurements that mobile stations usually they send periodically to the BTS. And these measurements, they measure the signal strength in the downlink side. Okay, so the mobile stations, they send these measurements to the BTS periodically on the uplink. So the base station itself, it averages out or it performs some moving average filtering to these measurements, and then it sends the averaged values to the BSC, because we said that the BSC is the component that manages the handover. So all the handover has to be managed and controlled by the BSC and the MSC as well in this particular case. So BTS will send the measurement results to the base station controller, and the base station controller, in that case, it decides whether we should do the handover based على ايه؟ based على measuring the the signal strength and comparing that with the handover margin between the old BTS and the new BTS. If there is like a decision, then this decision will have to go to the mobile switching center, and the mobile switching center will also decide whether this base station belongs to another BSC, in which case we have to engage the MSC for this geographical location. And then the MSC will start to trigger the handover between the old BTS and the new BTS. The concept here, تفضل.
That was between two different
BSCs, yes.
yes, different service providers.
لا مش different, لا 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 لا. We are all the same service provider. Even as we said before, the network that's owned by one service provider, it may have more than one MSC. Okay? Yeah, so this is not roaming. So yeah, so this is different from roaming. Here, handover happens within the same network that belongs to one service provider. Okay? So base station controller, MSC, all of these are within the same network. Okay? So there is no different service providers here. Service provider, it will be a totally different process. You see? Remember the concept here. The concept here is that handover follows the concept of make before you break. So of course, this MSC consumes some resources from this old BTS, right? But it needs to move to another BTS. Okay. So how can we do this? Because if we try to say, okay, so let's just move the resources from the old BTS to the new BTS. What will happen? What will happen is that there is a transition period in which the mobile station may not have any service, right? صح كده? Even if it's for 1 millisecond, few milliseconds, you dismantle the resources from one side and then you establish the resources on another side. This is what we call abrupt handover, and we never do this. This is not this is not what we want to do. What we want to do is graceful handover, which means we have to make before break. So in order to maintain and sustain the service, then we have to first establish the resources on the new BTS, right? And establish the link, and then go back to the old BTS and clear the resources. That's how we do it, which means that for a certain period of time during the handover, the mobile station consumes resources on both BTSs instantaneously. واضح? It consumes resources on both BTSs instantaneously. Okay? Once we make sure that the link is established to the new BTS, then we go back to the old BTS and then clear the resources. So the way to do this is that the MSC will send the handover request to the new BSC that this base station belongs to, right? And then the new BSC will perform a resource allocation. So BSC, as we said before, when we discussed the functionality, we said that BSC performs handover and it performs also the resource allocation. Resource allocation here is that how many physical channels do you need for this mobile station at the new BTS. So this is the process of resource allocation. So once you do the resource allocation, doesn't mean that you assign. So allocation is like to plan. To plan how many channels or how many time slots does this mobile station need on the new BTS. Like for example, it needs 2 time slots each, مثلا for each super frame. Okay? And that's assigned in one physical channel, one channel, right? We said that we have multiple channels, 124 channels, some for uplink and some for downlink. We said that. So once we assign the channel and the time slots, which is done by the BSC, then we do the channel activation. Channel activation, we send a command to the BTS to say assign this channel and this time slot to this particular node, right? Until then, we did not start to use these resources yet, which means that the mobile station, until now, it's still consuming resources in the old one, and it still uses the service from the old one, right? Until this point, okay? Even though the resources are allocated, but I cannot use them now, okay? Then if the acknowledgement is positive, then we send this acknowledgement to the MSC, and then the command will be sent all the way back to the mobile station to start establishing the link end-to-end between the mobile station and the new base station, okay? After this link establishment, okay, then we can start to consume the resources on the new BTS that has been allocated, okay? After we establish the link, this means that the service has moved completely to the new BTS. Only then we have to go back and say handover complete, which will have to go all the way back to the old BTS to clear the resources. Only then we can clear the resources. Okay? So from here, from this point, okay, all the way to this point, all of this time, the mobile station consumes resources on both sides. It has double the resources during all this time, okay? But this is the only way we can do the graceful handover. We have to do the handover in a graceful way, otherwise we will disrupt a service. We don't want to do that, right? Well, here, so that's the sequence. It's pretty lengthy, right? And again, it's based on the approach of make before you break. Okay. Any questions? Okay, so that's the sequence. Right. Another aspect of GSM is security. Of course, security has to be part of any system. So security طبعا is performed through the SIM card. The SIM card has a chip which actually stores in it all the identifiers related to that mobile station, right? And these identifiers will have to be used as part of the authentication and later on confidentiality and so on. So the way that we do this is that the SIM card stores what we call mobile service identifier or mobile station identifier or MSI. Okay, this MSI is a permanent number. The MSI is a permanent number, which is actually stored in the home location register. Okay. But of course, when طبعا احنا we don't expose that MSI in any way. So MSI is actually used to authenticate the SIM card or the mobile station indirectly, as we will see. But once the authentication is actually done, we have to use what we call a temporary mobile station identifier. This temporary is like equivalent to the session key or the temporary key, if you know these terms. So this temporary identifier or temporary mobile station identifier identifies not only the mobile station, it actually identifies the service that this mobile station uses in this location area. Okay, and it's different from the mobile switching identifier, which is the permanent one. Okay, which is used as part of the authentication. So of course, like any other security system, we need to have authentication. We need to have, of course, confidentiality, and we need to have key generation and non-repudiation and all of these services. Here, what we need to discuss is the three things: the authentication, encryption, and the key generation part. Okay. So the the authentication part is actually it's done through what we call challenge response method. So I will give you a puzzle to solve, or I will give you a number to solve, and then based on your mobile station identifier, okay, you can try to generate a response. Of course, the home location register stores that mobile station identifier, so it can expect a certain response. If you have the right mobile switch identifier, then you will produce the response that I'm expecting. If the response matches, then I authenticate the mobile station. So we'll see how this is done. Okay, and then we have to do confidentiality. Confidentiality is about concealing the information or the traffic that is sent from a mobile station to the base station. Okay, so yani securing the air interface and hiding the information by encrypting the information from the mobile station to the base station. For that, we need a key, okay, a symmetric key. So we need to do key generation process, which has to be secured, and once we have that key, we can use it for encryption. Okay, so so then the GSM ensures privacy by hiding the mobile station identifier, اللي هو MSI, and uses the TMSI, which is stored in the visitor location register of that particular geographical location. So you authenticate yourself once to the entire system, and then you are allowed to move within the same service provider. Huh? ماشي? You are allowed to move it to any location, right, in the system. When you move from one location to another, you always get assigned a new temporary MSI. Okay, so for every location you move to, you get assigned a temporary MSI, and that gets assigned by the VLR, or the visitor location register of that particular area. We said that each MSC has associated VLR, right, which stores some temporary identifiers or temporary parameters for this mobile station in this location. When you move from one location to another, you get assigned other parameters and so on. ماشي كده؟ The GSM for these particular security services, it defines 3 different algorithms: one for authentication called A3, one for encryption called A5, and one for key generation, which is called A8. So these are, of course, there are some other algorithms for security, for non-repudiation, but these are the fundamental ones. ماشي? So GSM in second generation, again, people who took يعني network security وكده, they will understand this better, but usually these algorithms are publicly available, usually, right? But GSM started with the concept that, okay, let's hide, or let's make the A3 and A8 proprietary or hidden, so they did not include it in the standard, thinking that this will make the communication more secure, or make the service more secure. Okay, but then that concept seemed to fail, because many of the service providers, they started to use very common implementation for A3 and A8, and that implementation was kind of known, and it's not part of the standard, but it's common, so everybody started to use it, and they became widely available, in which case GSM was not actually very robust in terms of security, and that became evident after few years of adoption, which promotes the concept of the fact that you cannot really make the service very secure by hiding these algorithms. It's not the right thing. So these algorithms, you have to assume that they are public. They have to assume that they are publicly available, but you have to make sure that the key itself is long enough and the key generation process is secure. Okay. So that's the concept here. So now, we need to go quickly through these algorithms to see how they are implemented. So the first one is for authentication, and as we said, this is based on a puzzle. I give you a puzzle, or I give you a random number, okay? And if you produce the response that I'm expecting, then you are authenticated, okay? Which is a very primitive authentication scheme, as some people might know. So we have the SIM card, okay, which is part of the mobile station, right? So this SIM card stores the main identifier of the mobile station identifier, and it stores also the A3 algorithm, which is supposed to be secret. However, it's not. Okay. On the other side, we have the authentication center, which is part of the operational subsystem. If you remember, it's part of the architecture. We said that GSM architecture has three major subsystems. One of them is the operational subsystem, which is responsible for performing all the security, authentication, and also the billing and so on, right? So part of the operational subsystem, we have the authentication center. So this authentication center consults the home location register, which stores the permanent information of that mobile station, right? And then it performs the A3 algorithm to produce what we call assigned response based on two parameters. This random number, or this is the puzzle that I gave you, and this key, or the mobile station identifier, which is a permanent key that's stored as part of the SIM card, right? And it's also stored in the home location register. So based on these two parameters, I perform the A3 algorithm, and then I produce what we call assigned response. Okay? So when the mobile station performs the same process, it generates also the assigned response. So if I use the random number sent from the core network and the same key, I should produce the same algorithm, of course. I should produce the same signed response. This signed response will be sent to the mobile switch center, and the mobile switch center will receive the response from both, from the authentication center and from the mobile station. It receives the signed response from both. And then it compares. If both of them are equal, then this mobile station is authenticated. And again, the mobile station is authenticated once. Once it's authenticated, then from moving from one location to another, all you need is a new temporary mobile station identifier. For each location you move to, you need another temporary key to use. Okay. So A8 is used for key generation. So I need اللي احنا كنا بنسميه في network security, if you remember, pseudo random function. The pseudo random function again is based on the same two parameters, but I use another algorithm for key generation. So based on these two parameters, again, which is exchanged between the authentication center and the SIM card on the mobile station, I can produce a key of length 64 bits. Okay. So if I use the same key and the random number exchanged and the same algorithm, I should produce the same key. Okay. So the same key is produced here and here. So this process, it has to be done whenever I move from one location to another. Okay. So this key has to be renewed every time I have to move from one location to another. So once I have this key, then I can use the the A5 is the only one that's publicly المفروض يعني it's part of the standard and it's publicly available. So A5 is used between the BSS or the base station and the mobile station. So this is the air interface. So here, this is the A. This part here is the air interface between the mobile station and the BSC or the base station. Okay. So we have the same key. It's symmetric key. طبعا it's not a private key here. So it's the same key, symmetric key, is used by the mobile station and the base station. Okay. Very very primitive يعني techniques. Of course, as we said, the A3 and A8 they became widely available and commonly used by different service providers, and later on يعني it became يعني not very robust, and that's why حتى in 3G they completely changed the whole thing. Okay, they made the algorithms طبعا publicly available from day one, but they strengthened the security through other means. But the concept is still the same pretty much. تمام كده? So this is basically second generation. So GSM has يعني give us some idea about the basic architecture for second generation, which has fundamentally changed the game, introducing the concept of handover and the multi-cell system, and the fact that the mobile stations can move from one location area to another and so on. So this architecture, by the way, if you understand it well, it's still maintained until pretty much 5G. Of course, lots of things have been added, but the basic foundation is pretty much the same. So even in ORAN, there is a new paradigm now called Open RAN, or Open Radio Access Network. They still use the concept of ORU and ODU, which is basically the BTS and BSC and these things. So these components have been maintained pretty much, but we will see how we change from one generation to another. Of course, GSM, as nice as it was at that time, but it provided data rates of around 9.6 kilobits per second, which was pretty much good for voice calls and for supplemental data services like fax and these things. But definitely it was not enough for real data services like multimedia services, video conferencing, and video on demand, and all the services that we have nowadays for granted. So 9.6 cannot really give you these fancy services by any means. So definitely there was a need to provide more advanced or more enhanced data services, right? But remember, one fundamental thing that GSM was based on was the fact that it provides circuit switched data. Circuit switched data was good, and it was actually at that time it makes perfect sense, because we are talking about providing mainly voice calls, and for voice we need circuit switched data provides guaranteed quality of service, right? Because we allocate a virtual circuit to every call, right? So if you allocate a virtual circuit, this means that the resources allocated to this particular call is permanent. ماشي? So if these resources are permanently assigned, then the quality of service is guaranteed, right? So everything is deterministic pretty much. So the only dynamics is based on the channel state, based on the fact that the mobile station may actually move further from the base station. That's the only factor that kind of changes the throughput. But other than this, assigning a specific time slot or a specific physical channel to the mobile station can allow you to deterministically calculate the expected throughput, pretty much. Okay, especially if you are using small cells. So definitely 9.6 was good for voice calls, but it was not good for providing any data services. On the other side, of course, at that time we had Wi-Fi and these types of technologies, which actually fundamentally based on providing data services, and data rates were really much higher, right? So at that time, they discussed the concept of conversions, that cellular network, they need to also support some data services. So there was a big motivation and need to increase the data rates at that time. So one fundamental concept that they thought about at that time is to try to increase that data rate, but with minimal changes in the architecture. Minimal changes in the architecture, right? So the architecture is fundamentally based on circuit switched. It was not even IP based. Yani IP was not in the picture at all in 2G. Okay? So we talked about the layered stack, and we did not talk about IP anywhere. IP was not in the picture, right? Because IP is packet switched, not circuit switched, right? So, so the question is, how can we increase the data rates without really fundamentally or significantly changing the architecture? Okay. So they came up with the 2.5G. 2.5G here talks about the fact that we need to provide higher data services with minimum changes to the architecture, ideally with some software upgrades. So we only need to update the software on the core network servers and the BTSs, and that's it. Okay. So the first introduction to 2.5G was what we call high-speed circuit switch data. Okay. By circuit switch data here, we mean that we still rely on the core of GSM being circuit switched, but we need to provide a higher speed. Okay, so how can we do this with minimum changes to the architecture? They talked about providing some software upgrades to the servers to introduce the concept of channel bundles. So what happens is that typically the mobile station, to achieve this particular data rates, it gets assigned one time slot on a particular channel, صح? That's what we talked about. So we have a super frame, which is composed usually of 8 time slots, right? And we have this in different channels. So a mobile station gets assigned one time slot on one physical channel, okay? So with this time slot on this physical channel, it can achieve a data rate of 9.6, okay? So, which is here. So typically GSM provides this using one time slot on one physical channel to the mobile station. So what we need to do is that in order to increase the data rate or make it higher speed, the HSCSD introduced the concept of what we call logical channels or channel bundle. So instead of assigning one time slot to the mobile station, we can introduce the concept of logical channel. Each logical channel is composed of multiple physical channels. Okay? So each one logical channel uses aggregation of channels or aggregation of physical channels. So a channel here meaning, or a transport channel meaning one time slot on a particular frequency. Okay? So if we assign one time slot to this particular mobile station, we achieve a data rate of 9.6. If we assign 2 of these, we get a rate of 19.2. If we assign 3, we get this. If we assign 4, we get this. Okay? So typically in GSM, what we do is to assign one time slot to on one transport channel to this mobile station, and that's it. Okay. So that's a simple addition, right? It's simple addition. It requires only some software upgrades to the mobile station as well as in the base station and the core network, and that would be enough. Okay, so in order to create some different data rates, so they try to increase that data rate from 9.6 all the way to 57.6. And that's done by assigning 4 time slots to the mobile station, okay? But these 4 time slots are assigned on physical channels that each one has 14.4 kilobits per second. So what is the difference between this rate and this rate and this rate? So the difference here between the rates is based on providing a specific coding scheme. So by changing the coding scheme, I can in fact increase or decrease the data rate. Okay? I can increase the data rate slightly on a specific transport channel. And if I increase the rate to 14.4 and assign on a channel that uses a specific coding scheme, if I assign on this channel 4 time slots, I can reach to that data rate. Okay? ماشي كده؟ So why not 8? يعني why not assign all the 8 time slots to the mobile station? That might be a question. يعني why stop at 4? Why not 5? Why not 6? Why not 8? Right? So in the standard of HSCSD, they talked about some limitations that forbids the use of more than 4 time slots. One of which is the fact that this requires the mobile station to be full duplex, which means that it has to send and receive at the same time on the same frequency, and that requires like full duplex transceiver. Full duplex transceiver requires new hardware on the mobile station, and they said, and again, the principle is to provide these services or these high-speed services without introducing hardware changes. Okay, so that was the condition. So if we assume that we have the super frame in the uplink and we have another super frame in the downlink, right? So the uplink and the downlink are both divided into 8 time slots, right? Okay. So if I assign all the time slots for uplink and downlink to the same mobile station, this means that this mobile station needs to send and receive at the exact same time, right? And that requires some hardware changes on the transceiver itself. It may actually require that, right? But if I restrict it to 4, I can assign these 4 time slots to on the uplink and these 4 time slots on the downlink, in which case I can support half duplex mobile station without any change to the hardware. I don't have to change the hardware in any way. Of course, in 3G, they made it full duplex from the beginning, but that requires the mobile stations to have support for 3G, and the hardware has changed, and completely there is significant change to the hardware and software. It's not only a software upgrade. ماشي? So there is some hardware limitation in the mobile station that forbids the mobile station to be able to use all the time slots in the uplink and the downlink. So there is limitation. And as we will see, حتى in GPRS later on, they also try to minimize the hardware changes for the mobile station by assuming that we cannot use all the 8 time slots by one mobile station. Okay, so the difference between these transport channels here is based on using some channel coding techniques, some modulation techniques. I can increase the data rates a little bit, right, from one to another by using adaptive coding and modulation techniques. I can do that. ماشي? And by bundling more than 1 or 2 time slots, I can increase the data rate. So they were able to achieve 57.6 kilobits per second. Of course, it's not a huge upgrade, but remember, this is done only by software updates, right? So that's يعني a significant upgrade, but it was not what we would hope for, right? Of course, in 5G now we're talking about, and 6G we're talking about close to 1 gigabits per second. So the difference is huge. But again, at that time it was a gradual upgrade. ماشي كده. So the only added thing here is the concept of channel bundle by introducing logical channel which groups multiple time slots on a physical channel, right? Using adaptive coding and modulation techniques to achieve different bit rates. So that's the only added thing, or the only upgrade. ماشي? So this was part of 2.5G. Of course, this was good at that time, but they wanted to actually يعني transition to packet switched services because we realized that circuit switched services, they always waste resources, because if we have to assign time slots or some resources to mobile station permanently during the call, then definitely the resources will not be used efficiently, right? At that time in GSM, of course, the billing and the charges were actually based on the time, even for data. If you try to have a connection to have like some data services, that's why they use like faxes and some very primitive services. You actually have to establish a virtual circuit, and then you get charged during the time that this virtual circuit is established, even if you don't use anything. Okay? If you make a phone call and then you put the headset on, you put the headset on the table and don't speak, you get charged, right? So even for data services, this was the case. So definitely, circuit switched is not really efficient in terms of resource utilization. واضح كده? So there was a need to try to provide packet switched services. So they introduced the concept of GPRS. GPRS at certain point of time was really big. I'm not sure if some of you يعني used GPRS in any way, but until maybe a decade ago, GPRS was actually very commonly used. Until maybe 10 years ago or something. Even حتى some of our students, they used to use it in the project, in their projects and so on. So GPRS بقى changing the game significantly. It's not a software upgrade anymore. Okay, it has to have a hardware cost. Okay, because of the fact that it's packet switched, so they started to also converge with the concept of Wi-Fi by using IP. So we started to use IP and packet switching and so on. But remember, we don't want to replace the existing architecture. So they tried to use like some parallel architectures, because we're talking about a transition from 2G to 3G. So they introduced new hardware, but as we will see, GPRS came with a parallel architecture which complements the circuit switched architecture of GSM, which means that GPRS introduces packet services in addition to the circuit switched services of GSM. So we need to add hardware, yes, but we need to also keep the old hardware. Okay, so we introduce new servers and new services by introducing GPRS. So So here بقى we can add some برضو data rates comparable to HSCSD, but here it's assigned temporarily. Remember, it's not a virtual circuit anymore. Okay, so I can provide with the same 4 time slots. I can provide 50 kilobits per second, yes, but this is assigned temporarily. So in every super frame, I can change completely the resources assigned to the mobile station. And if the mobile station does not have any data to send, I can assign it to someone else. Okay, so this is the difference between circuit switched and packet switched. So so the standardization for GPRS came in 98, and then it was introduced in deployment يعني in 2001, and that was the first step towards 3G. We'll try to give you some idea برضو about 3G and other generations later. But the disadvantage here was we cannot actually provide packet switched services without adding hardware to the system. And in fact, in GPRS, we'll see that the architecture is pretty messy because we have to have some servers related to GPRS in addition to the circuit switched architecture that we used to have for GSM. So GPRS introduced 3 major components which correspond to the MSC. You remember we have the MSC, the Mobile Switching Center, and we have the gateway MSC. And the gateway is sort of the open door to all the other networks. As part of this gateway, we have the interworking function, if you remember. An interworking function allows me to connect with any other technology like PSTN, like PSTN or ISDN or any other service provider or any other technology, right? And we have the home location register or the location register, right? Or the database that stores the information about the mobile stations, right? So here, these components 1, 2, and 3. These are the components that GPRS added to the system. So it introduced the concept of GPRS support nodes. GPRS support nodes corresponds to the MSC, exactly. But these components are packet switched components. These components, they use IP. Okay? So in that case, these components, they use IP. And in fact, the mobile stations using GPRS, in addition to the mobile station identifier and all of these identifiers, the mobile stations, they also use IP. Okay? In addition to the mobile station identifiers. So we have GPRS support nodes, which performs all kind of يعني handover and some of the management functions. It gets برضو involved in authentication, in billing, and so on. Okay, but in the packet switched side for data services. ماشي? And we have the gateway GPRS gateway support node, which contains the interworking function between GPRS and other technologies, and this corresponds to the gateway MSC. This serving GSN is actually the GSN in that particular location. So again, in every location we have GSN, and that's called serving GSN. ماشي? And because we have now like some addressing scheme, right? In addition to all the identifiers of the mobile station, we have now a new GPRS register, ماشي? Which stores, in addition to the mobile station identifiers, it also stores some addresses assigned to that particular mobile station. ماشي? ماشي? So far so good. أيوة.
The IP used only for the data, and not for the
right. Yes.
Not for the phone.
Yes, exactly. Used for the data, right. تمام كده؟ just wanted to say some. Of course, the IP assigned to the mobile stations, by the way, the private IP. So the mobile stations in a specific network or a specific location area, they get assigned a private IP, which means that part of the this gateway is to actually, in order to communicate with the outside, we have to convert
اللي هو الببليك اي
we have to convert from private IP to public IP. So this is the function of the gateway. So gateway also it changes from private IP to public IP in order to communicate to other nodes on the internet. ماشي? Of course, private IPs means that these private IPs are reusable. You can reuse it in different networks and so on, right? But it also has limitation in terms of assigning some server functions to the mobile stations. Mobile stations at that time, it was very hard to provide services as a server. Yani you cannot connect to the mobile station in a network because it does not have a fixed IP. It has a private IP. اتكلمنا عن الكلام ده في النتورك مش فاهم الناس فاكراه ولا مش فاكراه يعني. Private IP, one of the limitations of private IP is that you cannot easily connect to a private IP because it's hidden. You don't know it, right? Yeah, it's also يعني هو it can be reused. On the internet, private IP has no meaning, صح? What we use on the internet is public IP. We cannot use private IP, right? So the private IP is totally blocked. It's hidden. I don't know it. How can I connect to the mobile station if I don't know the IP address of that mobile station, right? تمام كده؟ اللي هو serving GPRS support node. Serving GPRS اللي هي current SGSN اللي هي serving GPRS support node. For each location you have a serving GPRS support node. اللي هي corresponds to the MSC بس in the packet switched side. Okay, we said that GPRS came with some added hardware, but it also keeps the old hardware as is. So we'll see the architecture in a bit. It become يعني very complicated. Of course, in 3G they converged and they made it all packet switched and all IP based and so on, but that happened in 3G though. تمام كده؟ Any other questions? أيوة تفضل. Because of the fact that here we're talking about packet switched, remember, as we said, circuit switched has a big advantage. The performance is somewhat deterministic because you have a virtual circuit. You have permanent resources assigned to you, right? So I would not expect to have a phone call and then have some يعني, voices up and down or some deterioration of voice quality or something like that. It should not happen because you have a virtual circuit assigned to the call. And this virtual circuit has permanent resources. So even if you are not using these resources, but the virtual circuit is established. So that's why in GSM and in also pretty much in HSCSD, اللي هو high speed circuit switch data, we did not care so much about quality of service. ماشي? Quality of service here talks about the fact that because here we are using packet switched services, the amount of resources are assigned temporarily, which means that in some point you can get more resources, in other points you can get less resources, right? And that might affect the quality of the voice, or some of the services might get affected. صح? But on the other side, packet switch is very efficient from the resource utilization point of view. So when I assign a resource, I assign it temporarily and for a very, very short period of time. In fact, it gets assigned per super frame. Okay? So I make sure that I don't assign any time slot to a mobile station that does not have any data to send. ماشي? So because of this, now I may have some يعني service quality dynamics. I may have some dynamic service quality. So but I need some assurance, at least the user, the mobile user, needs some assurance for the quality, right? So that's why GPRS defined the concept of quality of service, which was, by the way, it was defined in Wi-Fi and other technologies way ahead. But GPRS came with the introduction also of quality of service, and that's because of the fact that it started to use packet switched services. So the idea here is that, yes, you can give me dynamic allocation of time slots. You can assign temporary time slots. In this superframe, I have 0 time slot. In this superframe, I have 1. In this superframe, I may have 3, and then 0, and then. So there is like some dynamic assignment of time slots, right? But I need some assurance for the quality. Okay, so they define the concept of quality of service classes. Quality of service classes. So these quality of service classes, they are defined based on certain metric. One of them is based on reliability. By reliability here, we mean that we care about the dropping probability of service data units or packets. Yani. So packets, we need to have assurance for the dropping probability. So, for example, if a mobile station needs highly reliable quality of service, then it can be assigned class 1. And this class 1 provides loss probability or packet dropping probability of 10 to the power minus 9, which means that for every giga packets, for every 1 giga packets, I have only 1 packet lost. Of course, this is highly reliable, طبعا. ماشي? So how would I do this using the concept of temporary allocation? So if I notice that the mobile station is losing some service data units, ماشي? Then if I assign more resources to that particular mobile station, then I can increase the rate and then lower the probability of packet drop. Okay, so by assigning these resources and also controlling the, as we will see in a minute, the coding scheme, modulation scheme, by controlling these things, I can provide some assurance on average basis, of course. I cannot provide 100% reliability, or I cannot provide deterministic behavior, because here, remember, we're talking about packet switched. Packet switched services cannot provide 100% guarantees. ماشي? But it can define sort of يعني average based guarantees. ماشي? So if I see that some packets are being lost more, I assign more time slots to try to increase the data rates and reduce the packet loss. If I see that, okay, the packet loss is going fine, I can use مثلا less redundant bits for error correction, okay, and increase the data rate, or do the other way around. If I see some packets are being lost, then I can increase the CRC size, or I can use different modulation to try to increase the reliability or reduce the packet loss. Okay, so I can control the time slots, I can control modulation scheme, coding scheme, I can control all these things to achieve these quality of service limits. So if a mobile station requires very high reliability, I assign this mobile station to class 1. Of course, each of these classes, they have different price and different billing يعني methods and so on and so forth. For delay, here we're talking about the total delay between the mobile station and the base station. And that delay includes اللي هو transmission delay والhandover delay. Not sure if any of you started assignment 3 yet, but we have يعني different types of delay. فهير بقى we have برضو some assurance on the delay. And we have 4 different classes. Each of them provides different levels of guarantees for the delay. Okay, delay here is defined based on the mean delay and the 95% percentile. And what that means is that يعني when we say on the mean is less than 0.5 seconds, this means that the delay versus time, this is the delay may be going up and down, but the mean here is 0.5 seconds. As long as the mean is 0.5 seconds, then it's fine, or less, of course. The 95% percentile is that if you draw like this 1.5 second, then 95% of the time you are below that. Well, 95% of the time you are below that number. So that sort of controls برضو the fluctuations and the changes. I should care برضو about the fluctuation and the changes and make the delay sort of برضو يعني the delay fluctuations are less. Because if I consider only the mean, it can go really up and down. But as long as the mean is 0.5, خلاص. But the 95% percentile constrains the values even more. ماشي? Any questions? So these are, طبعا you don't have to memorize all these classes عشان برضو الناس ما تقلقش. You don't have to memorize all these classes. يعني we just need, we're talking about يعني we're just focusing here on concepts, and we need, of course, we need to memorize in a way the components, the subsystems, the functionality of each one, things like that, and the main concepts that we discuss along the way. But definitely we don't need to memorize مثلا this is the class 1 and it's less than 0.5 and so on. These are not to be يعني memorized يعني. طبعا class 4 here talks about unspecified, which means that like it's actually best effort. So there is no delay guarantees here. It's best effort. Okay, best effort means that I will try to deliver this, but the delay is not actually controlled or is not constrained in any means. ماشي؟ طيب, any questions so far? تمام. Is there anything else we wanted to say here? لا. تمام. تمام. طبعا error correction, احنا we did not study error correction techniques. We sort of hinted about error correction techniques. Error correction techniques are different from error detection. For error detection, we use checksum. Everybody knows checksum. Checksum is very easy, right? If an error happens, then through checksum you can detect that there is an error happen, but where you don't know. And usually with error detection, the only thing you could do is just to throw the whole frame, ماشي, and use retransmission to retransmit it. That's the only way. But in wireless, sometimes this is very costly. So in wireless, they usually use error correcting codes. Error correcting codes are يعني some هي similar to طبعا error detection, ولكن يعني it's a little bit more complicated. So this is the service data unit. And usually you add to it what we call CRC code or cyclic redundancy codes. These cyclic redundancy codes, these are redundant bits that has a combination of these, similar to the checksum, but يعني it's more complicated, so that if there is an error, not only you know that there is an error, you know the location of that error. ماشي? So if an error happens, you know the location of that error. So if you know the location, it's easy, صح? Because if it's 1, make it 0. If it's 0, make it 1. That's it. We have two states, صح? So by just knowing the location, we can correct it. تمام. So if you increase طبعا these CRC codes, if you increase the CRC bits, there are two things here. Of course, you can correct more types of errors, because there is burst errors, and there is like يعني يعني اللي هي errors that happens in consecutive bits versus the errors that happen. There are different types of errors. So if you increase the CRC, you can actually correct different types of errors, right? But on the other side, the overhead will be more. If the overhead is more for the error correction, then the data rates is less, right? And by controlling these CRC bits, you can in fact increase the data rate and reduce the number of errors you can correct, or reduce the data rate and increase the number of errors that you correct. So there is a trade-off, right? So if you know that channel now has higher probability of errors, then you increase the CRC and reduce the data rate, right? If you know that the channel is in a good state, then you reduce CRC and increase the data rate and so on. واضح كده؟ So that's also another way, or what we call adaptive coding schemes that يعني you can use to provide different types of data services. طيب. In addition to these traffic classes, so we talked about traffic classes. We define the traffic classes based on the reliability and based on the delay. We have برضو classes based on the device classes, or the hardware limitation of the device. The hardware limitation of the device itself, right? So the mobile stations also are categorized in terms of classes, and each of these classes refers to some limitations in the hardware. So the standard actually defines that. Why? Because this class will get communicated to the base station, so that the base station should expect ماشي how I can allocate the channels and what are the capabilities of this mobile station. Whether the mobile station can use 3 time slots at a time, 5 time slots at a time. So I need to know that. So for example, class 1, which typically similar to GSM, it uses 1 sending slot and 1 receiving slot. And in total, I can use 2 time slots for uplink and downlink. ماشي? So I can use 1 uplink, 1 downlink time slot, that's it. ماشي? But also GPRS came with the hardware updates. So there are some other traffic classes that for class 2 مثلا, I can have 2 receiving slots and 1 sending slot. So the uplink is different from the downlink. ماشي? So the downlink might be fast and the uplink is a little bit slow. And in total, I have 3 channels. So here we have 4 and 4, but in total I can have only 5. Which means that I can have 3 and 2, 4 and 1, ماشي? But the total has to be 5. So concurrently I can support up to 5 time slots. That's it. ماشي? I can use maximum 4 on the uplink, maximum 4 on the downlink, but in total I have 5. So that these classes refer to يبقى hardware limitations in the mobile station itself. You have a question?
Yes, I don't understand why sometimes the receiving slot and the sending slots are different. They should be the same, they are using the same.
لا why? لا. You know ADSL مثلا? In many services, by the way, we try to have the download speed higher than the upload speed.
Yes.
صح? Yeah. So
That's,
yeah.
even if it's same channel, but that's still different.
So the mobile station or the nodes, usually they consume data with a download speed higher than the upload. Usually, if I need very high speed in the upload, this means I'm working as a server. صح? But mobile stations are not expected to have like services as a server that much يعني صح? So usually the download speed is higher or the same. Well, so it's logical يعني.
Okay, the receiving slots and sending slots are Corcana ولا يعني
ما هو receiving معناها ايه؟ receiving معناها downlink.
not happening in the same time.
لا, these are happening in the same time.
But the maximum number.
The maximum, yes. This maximum is happening at the same time. So I can, like for example, for let's take this one مثلا. This one, 5. ماشي? For class 10, I can have 4 downlink time slots and 2 maximum uplink, but the total has to be 5. So I can have 3 and 2, or 4 and 1. These are concurrent. But this is uplink and downlink. And as we said, we explained this before. We said that we have the uplink super frame, right? And we have the downlink super frame. صح? So I can get assigned 3 and 2. ماشي? Or 4 and 1. Okay?
Why there is limitation?
This is hardware limitation. This is hardware limitation. And that also, as we said before, that also does not force mobile stations to be full duplex in terms of sending and receiving at the same time slot. Because this way, I can send, in the uplink, I can use different slots from the downlink, which means this is what we, if you remember, this is what we call TDD, or time division duplex. I don't have to send and receive at the exact same time because that requires different design on the transceiver. It's like you may have you need to have 2 antennas مثلا and 2 hardware replication to try to send and receive at the same time. Here I don't have to do that. I can use the same antenna, the same اسمه بيسموه ايه the same RF chip and the same baseband, ماشي? All of this is hardware which is attached to the antenna. I can use one hardware and one antenna, ماشي? And send on to different. In one time slot I can use it for transmission. In one time slot I can use it for reception. But it's the same hardware. If I want to send and receive at the same time, then I need to have a replication in the hardware. واضحة مش واضحة? It's like you have 2 chips. One is used for transmission and one is used for reception, and they have to use different frequencies. ماشي? And totally different hardware. But this way, I don't have to have this restriction. ماشي? If the maximum is 5, of course this was in 2G. طبعا nowadays we have we have full duplex طبعا by far يعني. We can send and receive on all time slots, and in fact we don't have only 8 time slots, we have much more. And we have طبعا full duplex transmission definitely. ماشي? But at that time 5 here means that this isn't the standard. Maximum I can use 5 time slots divided between uplink and downlink. So the mobile station can negotiate with the base station to allocate these time slots in uplink and downlink based on certain services and quality of service and so on. ماشي? Either بقى 4, 1, 3, 2, 2, 3, whatever. But the maximum has to be 5. مش مقتنع بقى. تمام. So that's these are classes based on the hardware limitation, not based on dropping probability or delay transmission. So based on that, simply GPRS defines the different data rates. هنا, this is the coding scheme. So the coding scheme here, by changing the coding scheme, we change اللي هي CRC redundant codes ديت for coding scheme 1 that uses the higher higher overhead of CRC bits or redundant bits, which means I can detect and correct very complex errors. I can provide reliability, which is very good, but it comes with some reduction in the data rates. واضح? It comes with some reduction in the data rates. So as you go here, as you go this way, you will see the data rates using the same number of slots. The data rates is increasing. Why? Because the coding scheme reduces the redundant bits, which means now I can correct less amount of errors. Okay? So if I cannot correct all the errors, then of course checksum will tell me whether there is an error or not. So some errors I can correct, some errors I cannot, which means I will throw this packet away and I will request retransmission. Retransmission, that means that you have to go through the delay. Good luck, يعني. ماشي? But in wireless, usually we don't want to do that. So I can use different coding scheme depending on the channel state. Then, depending on the channel state, I can try to use مثلا, hopefully, يعني, ideally, I can use coding scheme 4, which provides no error correction, by the way. So CS4 that provides no error correction, which means that I can use all the data for يعني, pure traffic, but I cannot correct any errors in that case. So that will give me high data rate. So if I use مثلا 4 time slots and a coding scheme 4, I can reach 84.6 kilobits per second, which is a significant upgrade compared to high-speed CSD. ماشي؟ واضح كده؟ So these coding schemes, they can be assigned dynamically based on a super frame by super frame. So for each super frame, I can allocate different types of number of time slots, different coding scheme, and different modulation scheme كمان. And I do all of this if and only if the mobile station has data to send. If the mobile station does not have any data to send, then I don't assign any time slots at all. Okay, this is the concept of packet switch service.
So if we go from 1 to 2, 3, 4, the delay increases?
Yeah, the possibility of retransmission increases. The possibility of retransmission. Possibility of retransmission if there is any error. If there is any error that you cannot correct كمان. يعني definitely مثلا CS4 ما فيش data correction أصلا. Okay. If there is any error, you will not know the location of that error. Hence, you will not be able to correct it. Then the only option you have is to go through retransmission. So ideally, I should not assign this coding scheme 4 unless I know that the channel state is perfect. مفروض يعني. ماشي? Or close to perfect. If it's close to perfect, then the probability of error is really low. So if there is one packet out of 1 giga packets or something, I can go through retransmission. مش مشكلة. It's not a big deal. But if I know that the channel state is bad and I assign CS4, يعني, that's not good, of course, because you have to go through retransmission over and over again because every error you cannot correct. So you have to go through retransmission and that will cost you some delay. Delay معناها quality of service degradation and so on. ماشي? Quality of service guarantees are not met. ماشي? طيب, this is the last slide and then we'll stop. ماشي? So this is the architecture. طبعا the architecture is cleaned a lot, but if we put the whole architecture, you will find that it's messy. So in addition to the BSS or the base station subsystem, the MSC, the home location register, and the visitor location register, and the operational subsystem, remember we talked about UM interface, and between here and here, we talked about the A-base interface and the A interface and so on. So these are interfaces in the circuit switch side. So now بقى, GPRS came with these nodes serving GPRS support nodes, and the gateway, our GPRS gateway support node, right? And the GPRS register. So GPRS register stores all the addressing of the mobile station. SGSN here performs functionality similar to MSC, but in the packet switch side, right? And because we introduce this hardware, then we have to define the interfaces. So now we have GB, GN, GI, which corresponds to, again, A base interface and the A interface, but in the packet switch side. ماشي؟ تمام كده؟ في أي حاجة تانية؟ I think this is pretty much it. So the gateway GPRS support node provides the GI interface, which interfaces this system with any other يعني technology, whether it's PSTN or ISDN or any other network. That includes other service providers. Here, but there is a new service provider, different service provider, different network altogether.
Same like IWF.
ايوه بالظبط. هو ال IWF is part of the GGSN. ال IWF اللي هو ال interworking function is part of the G, and also here part of it is again قلنا ال mapping اللي between private address or public address. All of this is done here. تمام؟ Any question in this architecture? So it's the same architecture like before, but we added these three components: the serving gateway, GPRS support node, the gateway support node, and the GPRS register. These are the three components that have been added. Any questions?
This is 2.5G.
This is 2.5G. Until now, we're talking about 2.5G. But this was a big step towards 3G. Big step towards 3G. We'll see that in 3G, they tried to merge and make it pure IP-based and packet switched networks from scratch. But that requires replacement of hardware, not only adding hardware, replacement of the old hardware. Old hardware has become not usable. Because كمان the technology has changed completely. احنا هنا we're talking about FDMA and TDMA, صح؟ هناك احنا we're talking about CDMA أصلا. الموضوع يعني اختلف جذريا. يعني اختلفت خالص. ماشي؟ طبعا nowadays بقى كمان اللي هو starting بقى 5G we started to كمان use the concept of cloud computing في الكور network. We started to have بقى virtualized resources. So I can request some resources from مثلا a cloud service ولا حاجة to provide on-demand services based on the number of users. If the number of users increase, I can add virtualized resources. If the number of users decrease, I can rent these services. I can rent the computational services on demand. ماشي? This is started to be introduced with 5G only, not before 5G. It came with the concept or with the paradigm of cloud computing. And nowadays we're starting to virtualize even the base stations نفسها. Base stations نفسهم كمان they started to be virtualized. That يعني later. تمام كده يا شباب? Any questions? Anything?